So what we're going to do today is A1 of the Putnam 2022. And in my opinion, this was pretty hard for an A1. So, it was to find all the ordered pairs of real numbers, A, B, such that the two graphs, ln of 1 plus x squared and ax plus b, intersect only once and not more. Now, you can make a rough sketch of ln of 1 plus x squared in your head. What would it look like? Well, at 0, it would have to be 0 because 1 plus 0 is 0 and ln of 1 is 0. So you just got to put that right there. And then it's probably going to be somewhat like a parabola here because if you recall, ln x itself is very similar to x as you near 0. And then it's probably going to flatten out, something like that. Who knows? So then, you'll have ax plus b, which is obviously just the slope-intercept form. So it's going to look maybe something like this is what we want a successful case to be. And maybe I could use green and red instead of red and green. So this is a successful case where it intersects exactly once. And let's see, in my rendition of this, it's pretty hard to get something to intersect twice, but there. That one intersects twice, while this one intersects only once. Now, let's figure out, what are the conditions for it to intersect twice or thrice, or I'm pretty sure the maximum is thrice, but however many times you want it to intersect. Yeah, you can actually get thrice if you draw very carefully over here. So, how do we get this perfect line is the question. Well, the solution is, of course, let's zoom in on our graph, which maybe looks a little bit like this, who knows, and we're going to take some point on it where presumably our line ax plus b intersects. Who knows? So now, what happens if, let's take the slope of this curve at that point in time. So let's take the derivative right over here. In fact, I'll draw it in both and perfect. Okay, so let's take that tangent line right over there. So now, what happens if we decrease the slope in that? Well, here's what's going to happen. Since the slope actually decreases over time, you can figure this out because it's 2x over 1 plus x squared once you take the derivative, and this one grows faster. Since the slope decreases over time, that means that once the slope decreases to a sufficient value, these two will actually intersect again. But if you make the slope high enough, it cannot intersect. Oh crap, I probably should have used green instead of purple. That's my bad. Now, there's actually something you can do kind of like this, in which case you're sneakily still intersecting the other graph. So what you really want to do is just be the best of the best. You want your line to be way higher than the slope of the tangential line at that point. So in other words, let's say these two have that intersection point at, I don't know, ln of 1 plus n squared, comma, an plus b. Who really cares? Now, we want to make sure that this slope, a, is greater than 2n divided by 1 plus n squared. So, these are essentially the conditions. if we have this point right over here with one intersection, then we have to find, we have to have a is greater than this. But still, we have to solve a little bit more, because, I mean, what actually does solve this? But I'll leave the algebraic part to you.